Hi, today we discuss about interactive atomic model simulation. Atoms are the fundamental building blocks of matter, and its structure defines the properties of all elements in the universe. This project is an interactive atomic model simulation that allows users to visualize and manipulate atomic structure in real time. By adjusting the number of protons, neutrons, electrons, users can explore how different and how isotopes vary, how different elements are formed, how ions are created, and how isotopes vary. The simulation dynamically identifies elements using real scientific data and visually represents atomic structure with animated electrons, orbits, and realistic nucleus. The purpose of the atomic model simulation. First, educational tool. This helps students and science enthusiasts understand atomic structures interactively. This demonstrates how changes in subatomic particles affect the identity and stability of an atom. Next, scientific exploration identifies elements, isotopes, and ionized states using real periodic table data. This uses the Mendeley Python package for accurate atomic information. After real-time visualization, displays the atomic nuclei and electron orbitals dynamically using HTML5 canvas and JavaScript. This animates electron movement for a more engaging experience. And hands-on experimentation, users can modify atomic structure by adding or removing protons, neutrons, and electrons, simulates real-world atomic properties, including ionization and radioactivity detection. This project bridges the gap between theory and visualization, making atomic physics more accessible and interactive. Next, tools and technologies. For this project, we use front-end HTML, CSS, JavaScript, back-end Django with Python, database not required unless saving your data. Next, physics simulation, JavaScript, Canvas API for visualization, periodic table integration. For that, mainly Python package. So, installation steps. Install Python and Django in your project. Check Python version. After that, install Django. For that, use this pip install Django command. Then pip install Django REST framework mainly. This is for Django framework installation command. After that, check the Django version if it's installed or not. Next, create Django project with this command. Next, go to the change the folder. Our project directory name is atomic simulation. Next, create a Django app for the simulator. For that, use this command. Next, go to PyCharm for writing the code. After After creating the project folder, this looks like this. So atomic simulation, inside we have 3 folders and these files. Inside the atomic simulation we have these files. After that, inside the simulator file folder, we create another folder like static. In that create another folder simulator. In that we create 2 files, script.js for JavaScript and style.css for CSS. And inside the simulator folder we create another folder, templates. In that we create another simulator folder. In that we create index.html file. And now we go to settings.py folder, py file. In that go to install apps and add these 2 lines in your file. This is for Django framework and this is our simulator app. Next, define API routes in simulator URLs. Open urls.py and write this code from django.urls import path from .views import element info. This is a class for API and this is the function for index.html file rendering, and these are the URLs for these 2. Next, go to index.html. I already write this code. So first link the CSS file into your index.html file and create a class div, container div. Inside that create controls for user input, protons, neutrons, electrons. After that create another div to display the find element name and canva for protons, electrons, neutrons visualization, and link the script file into your index.html file. Go to CSS. This is the body properties and h1 tag properties and container controls visualization with text align, position, element color, red color, display inline, font size, margin, bottom, and this is the Canva properties. Next, go to script.js file. First create constant canvas document.get element by id. This is for select the Canva element in HTML and create another constant ctx equal to constant.get contact 2D. This is for rendering 2D constant context to draw on the canvas. Next, give the canvas width and height 250 pixels 250 and let protons to initialize the protons, neutrons, electrons values first. Next, create a synchronous function to fetch element data from the backend. For that, create a function name, use try block, try and catch for error handling, constant response equal to Give the URL of your backend API. And put the data in this variable. Next, update the element name by using this data. If element is found, then display the element name. Otherwise, give the error message. After that, call the draw atom for update the canvas. Next, create a function for protons updation. First, protons we want give 1. Never go below 1 for protons. And document.get element by id protons count. This updates the UI. Next, call the fetch element data. This redraw the atom. Next, same like proton, we create neutrons, electrons, but neutrons can be 0 or more, and electrons also same as like proton. After that, create another asynchronous function. Update the name element in UI. Let element name element charge empty, isotope value is empty. If data.element name equal to data.element, this element name based on protons. Calculate the charge value for that protons minus electrons. This is the formula for calculating charge value, and display the charge. Next, create another function draw atom. This clears the previous drawing before rendering the new atom, and this is for nucleus is a blue color circle at the center. Next, draw protons. This is for protons, and I want to put the color for proton red. Protons are drawn in a circular pattern inside the nucleus. The angle distributes them evenly. Next, create for loop for draw neutrons. For let I equal to 0, I less than neutrons, I plus plus. Let angle copy the code and paste here. Just change some method.py method.max 1 comma. Here also 1 comma protons, 1 comma neutrons. Let canvas width, this is 20. Height also same 20. began path. Next I want to give gray color for neutrons. Neutrons are drawn similarly to protons but slightly outside them. Next create another for loop for electrons. For that let max electrons per shell 2, 8, 18, 32. Let electron index 0. Console.log drawing electrons Next create a for loop. Let shell 0 electron index less than electrons shell plus plus. Let orbit radius x equal to 40 plus shell into 20. Let orbit radius y orbit radius x into 0.6. Let electrons in shell math.min electrons minus electron index max electron per shell of shell by 32. For let I equal to 0, I less than electrons in shell I plus plus electron index plus plus. Let angle math.pi into 2 into I electrons shell let x equal to canvas dot height by 2 plus math dot sine of angle into orbit radius y. Let take y equal, this is for y, x equal to sin with cos angle radius x. Ctx dot begin path fill style. I want yellow color for electrons. Next, initialize everything on page load. For that, window dot onload equal to function fetch element data. When the page loads, to draw the initial atom, the script.js file. Next, go to views.py, that is inside the simulator folder views.py. So from django.http import JSON response. Create JSON response for API request. Next, from django dot shortcuts import render. This is render HTML page, and from REST framework dot views import API view. Base class for Django REST framework DRF views. Next, from REST framework dot response import response. This formats API responses in JSON format. Next, from menglib import element. This element fetches element data using the number of protons. Next, create a class element info, API view. This defines an API endpoint that returns element details. The API view makes this is a RESTful API endpoint. After that, create a function def get self comma request protons, neutrons, electrons. This function handles HTTP GET request when a client calls and accepts the protons, neutrons, electrons, and fetch element data using mendlib. Element of protons, element name, element dot name, element symbol, element dot symbol, next calculate isotope. For that, isotope to mass protons plus neutrons, isotope equal to element name minus isotope mass. Isotopes are variations of an element with different neutron count. Next, calculate the charge of the atom or ion. For that, charge equal to protons minus electrons if charge not equal to 0, else neutral. This is the formula for charge. If charge is not 0, it displayed as plus n or minus n. If charge is 0, it is neutral. Next, return response element name, symbol, element symbol, isotope, charge string. Next, handle errors for that. Write exceptions as E, return response str of E. Status 400. If something goes wrong, returns an error message with status 400 and helps in debugging API errors. Next, render the front-end simulation page for that. Create a function ref atom simulation inside function call request return render request simulator index.html. This loads and returns the index.html file inside simulator folder. This is the front end where the JavaScript based atom simulation runs. And let's run this project. So run the server, python manage.py, run server. Click on this link. This is the output of our project, interactive atomic model. Here is the element we find. If give protons 3, neutrons 3, electrons 3, it should here updates protons 4, 1, 2, 3, 4, neutrons 3 grey color, electrons 3 in yellow color, and the element based on this beryllium 7 ion plus. If I change the neutrons 4, beryllium 8 ionized positive charge, protons 4, neutrons 4, electrons 4, and beryllium 8 neutral. This is the output of project. Thank you.